Hello everyone. Uh, so in this session, welcome to the session of theory class of data structure theory class. So in this session we are going to talk about move on to the chapter number 5, that is stacks. Okay, so in this chapter we are going to talk about one of the most important and useful data structure, that is stack. Okay, so basically the stack is actually a set of group elements in which the addition and addition and deletion of the elements takes place only from one end, called as the top of the stack. If you remember, we talked about this in brief in the chapter number 1. The stack is something like a ordered group of elements in which the addition and deletion of the elements takes place only from the one end, called as the top of the stack. Okay, so if you look at here, we have something like some real world examples of depicting the behavior of the stacks here. Okay, something like you see stack of cafeteria trays, a stack of pennies, stack of shoe boxes, a stack of some shirts here. Okay, so now if you look at this behavior of this trays here, see all the elements are placed one over the other. Okay, and if for suppose, like if I want to add one more tray onto the stack, I should add it from the top, right? I should add it from the top, and if I want to remove it, I have to remove it from the top end itself, right? Getting the point? The set of tracks here, trays, what happens here, if any element is added here, it's going to be added only from the top end. If you want to remove it from this stack, the top one will be removed. Yani the addition and the deletion both are taking place from the top end. Then you cannot add any element from the middle or from the bottom, and you cannot delete any element from the middle or from the bottom. Like this kind of behavior is what we call is as a stack here. So something like if the element has been added here, okay, so the element which was inserted last, and if you are going to delete that element, that element will be the element which was inserted last. Okay, so that is what we call it as last in first out structure. Okay, hope you understood this. Okay, right. So so if you build this stack structure, what kind of operations do we need to be applied onto this structure? Okay, so basically, like, we have 5 set of operations here. One is to construct the stack, initialize an empty stack with no elements. So in the beginning we need to construct an empty stack and initialize the proper structure here. Okay, the second operation is empty operation. It finds out whether the stack is empty or not, whether the stack contains any elements inside the stack or not. Okay, and the two important operations, the push and the pop operation here. So push operation is nothing but addition of the element into the stack. Modifies a stack by adding a value to the top of the stack, whereas in the pop operation is the opposite of that, that is modifies a stack by removing the top value of the stack. Okay, so to do this push and pop operation, we need the top operation, that is it finds out retrieves the value at the top of the stack. Okay, we will talk about these operations in detail with the algorithms here, yani how we are going to implement it. Okay, so the next thing is like how these stack can be implemented. Basically it can be implemented in two representations here. One is the array based and other one is the linked list based. Okay, so here we are going to talk about the array based implementation of stack. Okay, so basically to build a stack class, what we need a array, and we need an array. We name it as, let us say it as a stack. To hold all the elements of that stack, we need an array. Okay, and also we need an integer variable. You can call this integer variable as top index, and this variable will show like which element of the array is at the top. Okay, yani it will indicate what is the element on the top of the array. Clear my point? All right, so now if you see here, we have this kind of stack here. Okay, and it is empty. So an empty stack indicates that the value of the top index will be -1, and if there is nothing in the stack, you can say that the top index is set to -1. And basically when you create an empty stack, what we need to do, we have to declare this array, and we have to initialize this top index to -1. Okay, please remember this. Like if the stack is empty, then we say that top index is initialized to -1. Okay, now if you see, if you add up two elements into the stack, A and B. Okay, so the top index is what? Is 1. Now if you see, this is A is 0 and B is 1. Okay, so which is the top element now? B is the top element, right? B is the top element. If I want to remove any element from this stack, which one will be removed? B will be removed. Okay, that is what last inserted element will be the first out behavior here. Okay, so if you add up two elements here, what is the value of top now? Top index is set to 1. Initially when the stack is empty, it is -1. Now if I add A, top index will be 0. If I add B, top index will be 1. Okay, understood? Right. So the definitions of like how it's going to be implemented in the algorithm and the Java implementation here. So basically the stack class we have, it is okay, it's a generic class. T indicates here it's a generic array stack class. So that means you can store any kind of elements in the stack. If you look at here, we have a stack array and its type is generic type, that is T. So you can store integer elements, you can store character elements into this stack. Any type of elements can be stored into this stack. Okay, and look at this, we have this one variable called as default capacity. Okay, this is the actually the maximum elements that you can store into the stack. If you want to define the size of your stack, you can define it using a variable called a def cap, or you can use any name here. Okay, the textbook has this name, so you can use this any name here for defining the maximum capacity of your stack. Okay, so for building a class, what we need a array called as stack, and we need a variable called as top index, and if you see here, we are initializing it to -1. Okay, so this is the constructor, and you are allocating the memory for this particular array here inside this constructor. Okay, right. So another operation that we have seen, that is is empty operation. Okay, is empty operation. So how will you, this operation is method tells you whether the stack is empty or not. If you look at this return type here, it's boolean, and it will return true or false. If the stack is empty, it will return true. If it is not, it will return false. So how will you say that? How can you identify that stack is empty? If you go back to the previous slide, we see that if top index is -1, we can say that the stack is empty. That's what. Okay, if top index is equals to -1, return true. That means returning true, nothing indicates here the stack is empty, else return false. Okay, very simple. If the value of top index is set to equals to -1, then the stack is empty. You have to return true. Okay, similarly, is full, and you have to identify whether the stack is full or not. Yani, how will you identify that? By the same top index variable. And if the top index variable reaches to the maximum length of your array or maximum size of your array of the stack, then the index is true. Yani, how will you identify the maximum size of your array? Using this length property. Okay, so if top index is equals to stack dot length -1, why is it -1? Because index starts from 0 here. Okay, so the total length of the array -1. If it is equals to that, I mean top index is equals to this maximum size of the array, then the stack is full, and you have to return true. Okay, very simple. If top index is -1, stack is empty. If top index is maximum size of the stack array, then it's full. Okay, clear? Now moving on to the push algorithm, push operation. So what happens here is, push is nothing but what? Adding an element into the stack, and you are adding some element into the stack. So first thing for adding an element into the stack is you have to check whether the stack is full or not. And if the stack is full, how can you add an element? So first condition is to check whether the stack is full or not. If the stack is not full, then you can add the elements. Okay, so what we are doing here, if the stack is not full, you have to just increment the value. Two steps here, two steps in the algorithm, in fact 3 steps. What is it? First you need to check whether the stack is full or not. If it is not full, then next step is to increment the value of top index by 1. Increment top index by 1 and store that new element that you are going to push or insert into the stack into that position, top index position. Stack is that array, and in the top index position you have to insert that element. Clear? See, if not is full. What is this is full? Is full is the operation to check whether the stack is full or not. If it is not full, then what we are doing? 2 steps. Increment the value of top index by 1, top index plus plus, and in this top index position you are assigning that element. Element is the argument here that you are getting from the push method. Okay, so this is the new element that you are going to insert. So that element we are assigning it into the top index position of that stack array. Okay, if it is not full, simply display that full. It's a full stack, yani. So throw some exception here. Okay, clear my point? I repeat here, if the stack is not full, simply increment the value of top index and store that new element into that stack. Okay, very important, please. These operations are very important, and in examination point of view, like you can say write an algorithm of push operation. Simple steps here you need to write. If the stack is not full, increment the value of top index and then store that element into that stack array top index position of the stack array. Else throw an exception that stack is full here. Okay, similarly the opposite of this push operation, that is pop operation, what we are doing here, we are removing an element, deleting an element from the stack. Okay, so similarly before deleting an element we have to check whether the stack is empty or not. Yani if the stack is already empty, what element you will remove? There is no point of removing an element if the stack is already empty, right? So first thing is to check whether the stack is empty or not. If the stack is not empty, simply decrement the value of top index here, okay, and make that deleted element as that position as null here before decrementing it. So what is that element that will be made as null? The top element. See, try to focus here please. See which element we are making it as null. We are making it as null, nothing but we are trying to delete that, okay, remove that. So the element which is at the top is the element that is going to be deleted here. Okay, so if you delete that element, the top index value will come down. It will be made as it will be decremented by 1. Okay, if the stack is not empty, we have to do these things. If it is not empty, simply say that the stack is empty, throw an exception here. Okay, understood? Very important please, push and pop operations. Okay, see a diagram of the example here, what we are doing. See, we have a stack here, the value of top is at this position now. This is 0, this is 1, and this is 2, right? So top is 2, right? So now if I call this operation push with 8 as an argument, yani 8 must be pushed here into the stack. So what happens here? The top value will be incremented by 1, yani the top will be 3 now, 2 to 3, right? And at this 3 position you have to insert this 8 here. Okay, now if you look at here, push of 2, what happened? The top value was at 3 now, 3 has been incremented to 4, and at this 4th position this 2 has been inserted. Okay, now after that pop is called here. Pop is what? To remove the top element, right? To remove that element. So which element will be removed? Neither 8, neither 1, neither 7, no, all these elements, no. The element which was inserted last, which is at the top position, see, at this position. So what is the position actually? It's 0, 1, it's 0, 1, 2, 3 and 4. So at the 4th position the element is what? 2. So 2 will be removed here, and you see the top value after removing 2 has been come down now, and it has come down to 3 here. See what we are doing here in the pop operation? We are decrementing the value of top to what? By 1. Okay, clear my point? Okay, so if you remove one more element, which element will be deleted? 8 will be deleted, and you see top has come to the bottom at this 1 position. Okay, so now again if you want to delete it, so 1 will be deleted and it has come to at this position, that is 1. Okay, hope you understood this. Clear my point or not? Let me explain over here again with another example. If I say here stack So now you see the top index. The top index. What is the value of top now? It must be -1. Must be -1. Why? Because the stack is empty now here. Okay, let us name this indexes here. It's 0, it's 1, it's 2, and it's 3, and it's 4. Okay, let us assume that this stack has maximum of 5 elements: 1, 2, 3, 4, and 5. Okay, so initially when the stack is empty, the value of top will be what? It will be -1. It will be -1. Okay, suppose now if I push some element here, if I push some element, push some element here, 80, into this. So after calling this operation, what should happen here now? What should happen? What should happen here now? The element top, which was -1, must be made as 0. And the first thing is to check whether the stack is full or not. So in the push operation, what happens? If you look at this push operation, first we have to check whether the stack is full or not. Yes, our stack is not full now, it's empty, and you can have the position. Okay, because top value is -1. If top is maximum position, then we can say that stack is full. Now top value is -1 and it's not full. Okay, so if it is not full, what is that we have to do? We have to increment the value of top by 1. Yani top will become what now? It will become 0. Top will become 0, and at this 0 position you have to insert this element. Yani 80 will be inserted at 0 position. Understood? Okay, so similarly, if I call another operation here, push, if I add another operation here, some 70, okay, so now what? The top value here we had in 80 here, which is already present. Now the top value was 0, it will be incremented by 1, and top will move to what? Top will move to 1. Okay, so top index value will move to 1, and at this 1 position you have to insert this 70. Alright, okay, so suppose now if I call pop, so which element will be deleted? Which element? The element which was inserted last. Yani what you will get now here? What you will get? You will have only 80 here. Okay, this 70 gets deleted. Okay, and this top value will come to the bottom, and it will be decremented by 1. See, in pop what happens? This index, current top index will be made as null and it will be decremented by 1. Okay, so now the top value is what? 0. Okay, understood? Right. See, we have this kind of problem here. Okay, this was asked in the previous exam, so try to understand this problem here. Very simple. See, you will be given with the capacity of an stack, that is maximum capacity is only 3 elements here. Okay, and the value of top index is set to -1. That means stack is empty here. Okay, so you will be given this one and you have to write all these, the value of top index and the stack status of the stack. Only this will be given. The one in the red will be given as a question here. Okay, this is the answer. Okay, and you have to write the value of top after this operation. Okay, so let us start here. What is the value of top here? In the beginning it is -1. Okay, so what operation it is? It is push operation. Now you have to increment the value of top -1 to +1, and -1 plus 1, it will become what? 0. Now at the 0 position the 20 will be inserted. Okay, very simple concept here. Okay, now what is the value of top? 0. Now again, if I call push with this 60, what happens? You have to check whether the stack is full or not. Be careful here. You see, when you are trying to add an or delete an element, you have to check the status of the stack, please. Okay, and if you want to push an element, you have to see that the size, maximum size reached or not. What is the maximum size? Only 3 elements can be stored here. Okay, so here we have only 1 element, so 1 more element can be inserted, right? So if it is not full, what we have to do? You have to increment the value of top index by 1, and 0 will become 1. 0 will become 1. Okay, and at this 1 position insert this 60. Okay, so 20 has been inserted at 0 and 60 has been inserted at 1. So now if I call the pop operation here, what happens? First thing is to check whether the stack is empty or not. Is it empty? No, we have some elements here. So how will you check the stack contains any elements or not? If the value of top index is -1, we can say that stack is empty. Okay, but what is the value of top index now? It is 1. Okay, so it is not empty. So if it is not empty, what we have to do? We have to just decrement the value of top index by 1, and 1 will become 0 now, and you decrease it. Okay, and the element which was at the top will be removed. Yani, what is the value of top here? 1. At the 1 position, what was that? 60. So 60 has been deleted here. Okay, so what remains? The value is top index is 0 and it is 20. Okay, understood? Now again, if I call pop, okay, so you have to check the value of top index. It's not -1. Okay, we have some elements. So now if it is not empty, simply decrement it to -1. That means 20 also has been deleted. Now the top index is -1. The status of the stack will be what? Empty. Yani no elements here. If 20 has been removed, first we removed 60 and then we removed 20. So what remains? Nothing. Nothing in the stack. And you see, if there is nothing in the stack, the value of top index is set to -1. Okay, again if you call this pop, okay, will it be in goes to -2? No, and we cannot directly decrement the value of top index here. First we have to check whether the stack is empty or not. So how will you check it? If the value of top index is -1, then stack is empty. Yani you have to do the decrement the value of top index only if stack is not empty. Okay, if the stack is empty, simply the value remains the same, -1 and empty. Here also you see it is -1. Okay, all right. See, you are again calling this pop function, so it will be -1 and empty. Now at this position I'm calling this push. Okay, so now what happens in push? Simply increment the value of top index. -1 will be made to 0, and at the 0 position you have to insert that new element, that is 80 will be stored in 0 position. Now simply again 50, that at this 1 position increment the value of top from 0 to 1. So at this 1 position 50 will be inserted. Hope you understand this exercise, please. Very important. Okay, and very simple as well. All right, so very simple what we have studied today. The definition of stack, okay, and what operations we have on stack, and the array based implementation of stack, that is what we need for building a stack class. We need an array and we need a top index variable, and it is initialized to -1 in the beginning when an empty stack is created. Okay, so that is what we have to declare this stack, and we have to declare this top index, and it initialized to -1. Okay, and to check whether the stack is empty or not, we have to check the value of top index whether it is set to -1 or not. If it is, the value of top index is -1, we say that stack is empty, and if the top index value is maximum -1, then the stack is full. Okay, and we have another operation, push, to insert an element. If it is not, the stack is not full, simply increment the value of top index and store the new element into that top index position. Okay, and pop, if it is not empty, if the stack is not empty, decrement the value of top index by 1 to remove that element. Okay, understood? Hope everyone understood the concept of stack data structure here, the behavior. Okay, all right. Okay, so moving on to the next topic now, that is the application of stacks, and we will see where these stacks can be applied, where this structure can be applied to solve some given set of problems. Okay, so we will see some scenarios here. So one such application is evaluation of the postfix expression. Okay, we will try to understand what is this postfix expression first, and then we will see how we can evaluate the postfix expression using the stacks. Okay, so if you look at here, basically mathematical arithmetic operation expressions, we have a plus b. Okay, it's like c minus d or any kind of. So what we have here, basically when you write an expression, we have two operands, a and b are the operands, and plus is the operator. Okay, so that means you have an operator here in between the two operands. Okay, so this type of notation we call it as infix notation. This is the general notation that we use in the mathematics generally. Okay, but the same expression can be expressed in different notations actually. Okay, one is such notation called as Polish notation or prefix notation. What happens here in prefix notation? We have something like a plus b. That means the operator will be written first and then the two operands plus ab. Plus ab means nothing but a plus b. Okay, and we have another type of notation called reverse Polish notation. Okay, and this one is also called as postfix notation, postfix expression. What happens here? Postfix means after the operands. yani AB plus, and A plus B nothing but AB plus. Okay, you see C minus D nothing but CD minus. E star F, E multiply F nothing but EF star. G by H nothing but GH divide. Okay, understood the postfix expression. So basically when you want the system calculates the expression, any mathematical algebraic expression, it calculates it using the RP and the postfix notation. Okay, so we will see this how a postfix expression can be evaluated. Evaluated means solve the expression. Okay, how the system can identify this expression, postfix expression, and solve it. See, we have this postfix expression here, 2 3 4 plus 5 6 minus minus star. See, 2 3 4 are nothing but the operands, any A B C, like this, A B C D E F. We have the values here directly. Okay, so what we are doing here in the postfix expression, first thing is we have the steps here. Fine. What is that? Scan the expression from left to right to find an operator. You have to start it from the left and keep on going to the right. Okay, and see, we started from here, let us say 2, right, and move on to 3. 2 is an operator? No. 3 is an operator? No. 4 is an operator? No. Plus is an operator. Now if you find a operator, what you have to do? Move on to the second step. What is that? Locate the last 2 preceding operands and combine them using this operator. Locate the last 2 preceding operands, any previous operator. You see here we have plus, so you have to find out the previous 2. What is the previous 2 operators here? Operands 3 and 4. So apply that 3 and 4 with this operator, any this line, underline, you see this one. So apply this 3 plus 4. What is it? 3 plus 4, it is 7. So after you apply this, what happens now? You will get 2, 3 plus 4 will be 7, 5, 6 minus minus star. Again repeat until the end of expression is reached. Again you need to move on to forward now. Now you have 2, 7, 5, 6 minus minus star. Okay, so 2 is not an operator now, 7 is not an operator, 5 is not an operator, 6 is not an operator, minus is operator now. So what happens now? Minus will be applied on the previous 2. What are the previous 2 with minus? 5 and 6. So 5 minus 6. 5 minus 6 will be what? It is minus 1. Okay, so you have 2, 7. This will be output as minus 1. You see, we have 2 minuses here. Don't confuse here, please. Here, see, this one is minus 1. So this underlying value will be minus 1. And what we have? Minus and star. Minus 1 minus star. Okay, so again check the scan the expression from left. 2 is an operator? No. 7 is an operator? No. Minus 1 is an operator? No. Now we have an operator minus. Okay, so this minus will be applied to 7 and minus 1. So that is 7 minus minus 1. Okay, 7 minus minus 1 is 7 plus 1, 8. So 2 and 8, and what remains? Star will be remains. So 2, 8. Again scan the expression, 2, 8 star. 2, 8 star is an operand. So now this will be star will be applied to 2 and 8. It will be 16. Okay, understood? I'll explain it again. See, let us say an expression, let us say. Okay, so what next now? 2 is an operator? No. 5 is an operator? No. 3 is an operator? No. Minus 1 is an operator? No. What is operator now? Plus. Okay, so plus is an operator. So this plus will be applied to what? Okay, let me not confuse you. I'll make it as not minus 1, only 4. Okay, so what happens now? This plus will be applied to 3 and 4. 3 and 4, right? So what happens now? What we get? 3 and 4, if I apply plus, it will be 3 plus 4, that is 7. So now I will get 2, the 5 the same, this value 3 4 plus will be, we get as 7, and what remains now? This will remains. What is remained? 4 minus star. Okay, again now 2 5 7 4 minus. Now you see, minus is an operator. Now this will be applied. Minus will be applied to what? To the previous two operands. Plus will be applied to previous 2, 3 and 4. Now minus will be applied to 7 and 4 here. Okay, so what will be the value now? 2 and 5 will be the same, and 7 minus 4, that will be 3, and we have what remains? This one, minus and star. Okay, again 2 5 3 minus. Now minus is an operator. Now minus will be applied to 5 and 3, that is previous 2. Okay, so now 5 minus 3 will be what? 2. So 2 and 2. What remains? Star is remained. Okay, now again scan the expression. We got star, and star will be applied to the previous 2, that is this 2. Okay, so finally what we get? Star will be applied to 2 and 2, that will be 4. Okay, so the value of this expression is what? Is valued to 4. Okay, understood everyone? Right, so this is how postfix expression will be evaluated. Now how this expression will be evaluated using the stack, that is the main point that need to be focused here. Okay, now you see here, we will see this expression. Now another example. Listen carefully please everyone. See, we have this expression 2 10 plus 9 6 minus division. Okay, so first thing is to scan the expression from the left. Okay, so if you find an operand, simply push it into the stack. Okay, if you find an operator, then pop out. Okay, what is the step here for postfix expression, evaluation of postfix expression? If you find an operand, then simply push it. 2 is operand, you are pushing it into stack, that is 2. Okay, and then 10 is also an operand. Okay, push it into the stack. 10, 2 and 10, we have it here into the stack. Now you see what we got. We get plus. Okay, as soon as you get the operator, plus is an operator, right? Plus is an operator. Now when you get plus as an operator, what happens? Simply pop up the two elements from the stack. Pop up the two elements from the stack. What we need to pop? So it will be pop first, 10 will be popped first, and 2 will be popped second. Okay, so what we have 2, and when you pop this operands, apply the operator plus. So 2 plus 10, we get what? 12. Now after you get this 12, the output, simply push that into the stack, and 12 will be pushed into the stack again. Got my point? Okay, so this one is done. Now what remains? 9. 9 is an operand or operator? It is an operand. So 9 will be pushed, 6 will be pushed. Okay, now minus. When you get minus an operator, what we need to push? Pop up 6 and 9 will be popped up, and that minus will be applied here. 9 minus 6, that is 3. Now 3 will be pushed into the stack. The output will be pushed into the stack. Alright, getting my point or not? Very simple, please. 2 and 10, these are the operands. Simply push into the stack. When you find an operator, pop it, apply that operator, and push the output into the stack. 2 and 10 are operands, pushing it. Okay, when you get an operator, pop it, apply that operator, and push the output into the stack. 2 and 10 are operands, we pushed it. When we get plus an operator, we popped up, applied that plus here, and we get the output as 12, and that 12 we are pushing it again back into the stack. Okay, now 9 and 6 are operator. Next, after plus, what we have? 9 and 6. 9 and 6 we pushed it to the stack. Now after 9 and 6, what we have? Minus. So minus is an operator. Now simply you have to pop up the two elements, 9 and 6, apply that minus onto that 9 and 6, we get what? 3. Okay, and 3 will be pushed again, the output will be pushed again into the stack, right? Okay, so after minus, what we have? Division, again an operator. So what, when you get an operator, simply pop up the two elements, 3 and 12 will be popped up, and that 12 by 3, the output, what we get? 4. That 4 will be pushed up, and finally after you finish the expression, you have to pop up the last element, that is what we get, the expression value. Okay, so finally we get what? Pop the answer as 4. Understood? So this is how a postfix expression can be evaluated with the help of this stack structure. Understood? Okay, so we will stop here, and next another type of application, that is infix to postfix conversion, yani how to convert an infix expression to postfix expression. We will talk about that in the next class. Okay, we will stop here.